So let's talk about spreadsheets. So one thing that we have been working on a little bit going through last year and years before is keeping the math that we do somewhere so that we can actually find it again. We've had some instances where we do some math to determine how we're going to design our robot and then lose a sheet of paper, right? And then the next day we do the same math and then lose a sheet of paper. The next day we do the same math again over and over and over and repeat our work over and over, which drives me crazy and then involves me talking about spreadsheets a whole lot. So here we are with an actual presentation about it. So a little bit about me, quick. I'm the lead mentor, head coach for 2239, the Technocrats out of Hopkins High School. I'm also an alumni of the team, or an alum of the team. And then for my day job, I'm a machine design engineer at General Mills. So I use a good variety of spreadsheets to do computations, keep track of things, and generally do my job. So on the participants button in Zoom, if you click that, you have some options around yes, no, and a few other things that you can click. So I just kind of want to get a feel for who's used a spreadsheet before at all. All right, so Google Sheets, Excel, whatever Apple calls it, cells, maybe. All right, so we got a bunch of yeses. Has anyone ever used a spreadsheet that they download from somewhere, or a calculator that they pulled from Chief Delphi? Like John Von Neumann has a calculator that's pretty well known, or AMB has a calculator. A couple of yeses, a few no's. All right. Has anyone ever used a whole sheet of paper to do one simple calculation because you do the calculation and as soon as you get done, someone comes in and goes, well, actually, we're going to use this motor, or actually, we're going to use, it needs to be this long, or actually, it turns out it needs to be a little bit smaller. All right, that's a common issue on our team. So we get through the calculation and then someone will come in and go, well, I recalculated my portion and it was off by 2 inches. All right, that helps. So since everyone's used spreadsheets before, I'll probably speed through the terminology stuff. We'll also cover some uses of spreadsheets, write in a formula, where do you go for help, how I like to organize my spreadsheets, features that you can use, and depending on time, we can dive into them, or depending on what people are interested in, we can dive into more of the more advanced features available. And then I have a variety of examples that I've done or pulled from the internet of spreadsheets and different things you can use them for. Cool, any questions? All right. Cool. So first thing, and warning here is spreadsheets are like CAD or code, right? People have strong opinions about how they're formatted or how they do them or what's going on with them, right? So just bear in mind as I discuss things, some of these are my opinions. Some of them are things that people will be adamant they need to be a different way. So really it's about what works for you and what works for explaining it to other people. And as long as it's clear, it really doesn't matter how you do it, as long as it's clear and correct. So a few uses for spreadsheets, right? So being an engineer, most of my spreadsheets involve around doing math and engineering calculations for things, right? And I very rarely do calculations by hand anymore on a sheet of paper, right? When you go through math class in elementary school, junior high, high school, right, even into college, they say, you got to write it on a sheet of paper, you turn on a sheet of paper, you're doing the problem once, maybe you do maybe a few of the same type of problem, right, and go on. And they give you all the numbers to start, and that's great. But when you get out into more real world situations, or like FRC, for example, you come in and you go, well, the arm could be 20 inches or 24 inches or 28 inches or 30 inches or any number in between, right? I don't exactly know what I want and it's not always easy to solve down for the exact thing you want, right? Or a lot of times you have um, more variables that are undefined than you have equations. And so there's not one solution. So you're going to try a bunch of different solutions. So spreadsheets are great for this, right? Give you an easy way to try some different values, speed up common calculations you do over and over, like gearboxes or moment arms or things like that. And then they also give you a nice easy way to make a spreadsheet for someone else, and then they can put in the numbers and get a nice answer without necessarily having to understand all the math. Also used for storing and analyzing data, finances and accounting. You know, a lot of your high schoolers, you probably don't keep track of all your finances. In the near future here, spreadsheets might be your best friend for keeping track of where your money is and what you're doing with it. Henry was talking about that I didn't find any embarrassing spreadsheets, and probably most of those had to do with project management and trying to keep track of who's working on what and what's going on and when are we going to get done with things and scheduling and whatnot. And then a big thing of note here is that because spreadsheets are so ubiquitous and people understand them, sometimes they get used in places they shouldn't be used, or sometimes you know, starting with a spreadsheet is the right move, but as you gather more data or you get more involved, especially in a professional setting, it maybe needs to migrate from a spreadsheet into a database or a full-fledged application, right? And so be mindful of when it's time to move on from the spreadsheet to something else. So we've got spreadsheets, we've got sheets, formulas, formatting, functions, rows and columns. More or less everyone said they've used a spreadsheet, so I'll jump through. I think the big one is I use spreadsheet to talk about the whole document, right? So an Excel file is a spreadsheet. The individual tabs at the bottom are sheets, right? And I try to stick with that terminology, but I may slip up here and there, and that helps in conversation with people if you stay consistent with what you're talking about. All right. So probably already know this, but you know, if you want to move around in a spreadsheet, right, you can click on a cell to jump anywhere you want. You can use the arrow keys to move around. One that some people don't know is that if you hold shift, it reverses the direction of tab and enter. So especially if you get into a data entering situation, right, where maybe you're typing in a bunch of numbers to record something that was handwritten, using enter and tab can be really easy, or you're typing out a big list. And so you can use shift and enter so that you don't have to move your hands from the letters on the keyboard to the arrow keys to move around, or move your hand to the mouse. All right, and then holding shift is how you get multiple, right? So you can always click and drag to get many, or hold shift to use the arrow keys, right, to move around. And then if you want just specific cells, so you can hold control and click through them, right, to get very specific cells that you want, which is one that people sometimes don't know when they're new to spreadsheets and can be very helpful if you want to go in and delete very specific items. All right, any questions?
And guys, you can go ahead and unmute yourself, or if you don't prefer to speak, you can use the chat for asking any questions.
Yeah, I know this is pretty basic right now, but we'll get into it. So for formulas and spreadsheets, right, it needs to start with a equal sign, always, to get it to actually calculate. If it doesn't have an equal sign, it's just going to display whatever you typed. Some people like to use the formula bar at the top of a spreadsheet, right up here, to write out their formula. Some people prefer to just write it in the cell. It goes to both places wherever you write it. For me, it really just is what I end up clicking on. There's no rhyme or reason one way or the other. The other big ways to get formulas entered into cells is dragging from another cell and copy and paste. And watch those closely, because when you do that, it keeps the references or the relativity to other cells, and so it can affect how the formula is calculated, which sometimes is very noticeable and sometimes is not very noticeable. So you just got to be careful with how you watch that or how you do that. We'll talk about that in a little bit. So a lot of times you write out your formulas, and you're starting to try and it comes back with an answer that doesn't make sense, or it tells you that it can't even calculate something. So there's a variety of different ways you can actually debug that formula. My favorite is use the color coding. So we'll use this example here. You can see up in the formula bar here, I've got equals B4 over B5, right? And when you click in the formula bar, and this is the same for Google Sheets or Excel, it will color code those cells, right? So you don't have to, it helps you when you're going through, right? You can figure out what B4 and B5 is, but it points out exactly where those are. And that gets really nice when you have a lot of cell references in a formula, right? And keeping track of which one goes where. With more complicated formulas, especially in Google Sheets, the parentheses will actually color code to match up. So the open and closed parentheses that go with each other are both red, and then the next set will be both be blue, and then the next set will be purple, and so forth, right? So if you're having a problem and things aren't quite calculating right, looking at the color coding on those parentheses can be big. All right. Since you've all used spreadsheets, you probably know where to find the help. I am partial to the help in Google Sheets because if you, especially with functions, clicking on the function itself gives you a nice little drop down that explains with an example what it does and what the actual values mean or what it's expecting, right? Because not all functions require numeric values. Some of them require, or especially if you're working with text, it can tell you whether it can take text or it has to take a numeric value, or it can deal with some of the values you give to a function are actually settings of that function that you're choosing. Same thing with Excel, right? If you click on the function, you either get a pop-up here or up here, and it will give you more information. Really handy when you're using a function you haven't used in a while to get you a little bit of a reminder of how that function works. All right, so now we're getting to the actual useful stuff. We're getting past the basics. So the big things to remember when you're putting together a spreadsheet, right? Especially if you're going to share it with other people or you're going to use it later in the future, is keep your formulas small, right? It's tempting to write, have one cell that does all the computation and pulls values from, say, 8, 10, 12 different cells and does all of the checking against different things and has if statements and it's basically a whole little program in and of itself. But that makes it very, very difficult to debug when there's an issue or to confirm that it's correct. And so it's preferred if you keep them very separated, right? So break them into small pieces. So in this example, right, I've got a motor with a nice speed and torque value. And then I've got some stages to a gearbox, and then what's the output of the gearbox, right? And these could easily write all of this into one cell. So that took in this output speed cell, could have taken the values of the driving and driven gears for stage 1 and stage 2 and all the motor specs and pumped out the actual value, right? But in doing so, you just add quite a bit of complexity unnecessarily, right? Plus it just makes it more unclear of how you did your computation and what's going on. So I like to break them out as much as possible and just do one step at a time, right? As like your math teachers tell you over and over again, do one step at a time and write them all out in paper. Same thing in spreadsheets, right? Just break everything out. Comment to your sheet, right? Like I said, your spreadsheet is basically the same as robot code, right? Or your CAD documentation, right? You really should comment or talk about what the intention is or what the purpose is and really what's happening in each individual step. I did not add any comments here, right? And this one's fairly simple, but just some nice comments off to the side can clear things up just a little bit, especially if you're handing it to someone else and expecting them to put in numbers and give you results, right? Then having those comments helps them figure out what should go in here, what's a reasonable value, right? Diagrams, images, anything you can, I like to use diagrams sometimes over words. It just helps clear up what's going on and what's working on. So here's an example from our team last year. Over here, there's a diagram they put together. Zoom out. This was actually made in Google Sheets here. We just did insert drawing, right, and created this nice diagram. So this is a calculation they did for a 2-stage telescoping climber, right? And so they're trying to determine the lengths of the tubes to go together to get the full extension that they need and get under the height that they need to fit it inside the robot. Right, and so you can see the top here, across the top was the first version of the computation, and they just wrote out what each variable was and then put in the values, right, and went through and just kept going sideways. And the words help and you can kind of understand what's going on. The picture definitely helps in clarifying that. Then the second version down here is they actually broke out the individual values and just wrote it in a little bit different format, right? So they've got constants for the robot, constants for the field that aren't changing, and those are entered values that are staying static. And they aren't changing for one calculation of this, but they might come back and go, I think the hook actually needs to be 5 inches, right? And throw that in and change that. And then they have the actual computations. We ended up doing this spreadsheet because we'd done the same math. I don't know, Henry, what do you think, like 10 times? Easy, because we lose the paper or they do the computation and then talk to someone else and go, oh, your thing's actually 10 inches tall. We thought it was 8. All right, we need to redo the math, right? And so we ended up with several sheets of paper of the same thing, and we couldn't remember which one was correct or what we were going with, right? So by doing this spreadsheet and keeping it, instead they were able to do the math once, and when they come back and find out that something needs to be changed, tweak that number and let everything else update accordingly, which in this case, the max height is the only thing affected by hook length. We'll change this to 5, and you can see. All right, it is changing. Cool. It's getting a little bit different values there. Right, so by doing this and putting the math in the spreadsheet, right, this is not hard math, right? If we look at these formulas, we've got, some subtraction, some addition, some more addition, some subtraction, some addition, and some subtraction and addition, right? Like this is grade school stuff. But by doing it in the spreadsheet, right, and if I get updated information or I learn something new or realize that it doesn't work, changing tube overlap to a different value, right, calculation's done, right? 2 clicks and you're out. So doing a lot of your math in spreadsheets gives you that ability to just rapidly do those and get that computation out of the way in your design process. The other big ones to help with clarity are using colors. Don't go overboard, right, with them, and using white space. So I like to say that cells are free, but people's time isn't, right? So you're not charged by the number of cells you use. It doesn't matter if it takes up, a 10 by 3 grid or it takes up a 20 by 50 grid, as long as it's clear to people and then you can save them time from having to cut through every single cell. So like this example here, I've got a little bit of color, got some white space to break up the different sections. I'm using 3 colors, which is pretty common for my spreadsheets. I've got one to call out titles, one for values that you actually input, and one for values that are calculated, right? So that you're very clear on what values are based on other things you've entered and what values are open to change. Right? So in this case, you're specifying your driving gear and driven gear and you get gear ratio, right? If we wanted to do it a different way, I'd probably make a separate sheet that goes through, give me a gear ratio, and then I'll tell you what driving or driven gears to use. Questions, comments, statements of concern? All right. So moving on to some more useful features. So I talked a little bit about copy and pasting with formulas, right? So I think the best way to figure out kind of what the behavior is and what happens with formulas when you copy and paste them is to make a little spreadsheet on your own, right? Throw in some basic formulas that you expect, some addition, some subtraction, multiplication, right? Whatever that you really understand, and then copy and paste them to different areas and see what happens, right? And kind of get a feel for how that works. There is a consistent set of rules, but it's like I before E, where there's a variety of layers to it, right? I before E except after C, words that sound like A, and other exceptions, right? The copy and paste of formulas is kind of the same thing. So anytime I copy and paste formulas, I always go and check and make sure it actually says what I expect it to say or is going to say. Because say we copy this one. All right, so I copied B18 over to E18, and we can see B18 was B14 divided by B6 divided by B11, right? And in E, since I'm in the same row, it kept the row values the same, but it changed the column, right? So now everything's E. Same thing if you drop it down one cell, it kept the column values the same, changed the row values, they all decreased or all went up one, right? It went down the sheet one. So you can see how you can very quickly screw up as you're copy and pasting values. The same happens when you drag cells with formulas, right? We get the same deal here, and it looks like here we break our reference because there's nothing above E1. So same deal. The easy way, if you really want to drag formulas or expand them or to make them calculate on multiple options, is you can use the $sign as an operator. So if you go in and add a $sign in front of the B, right, in B14 here, and I'll add one in front of the B in B6. That makes it always stay B whenever you copy it. So even if you move to a different column, right, see that still says B. The row value changed, right? So now we've got B11 instead of B14, but the column designation stays exactly the same. You can do the same thing if you go in and put $sign in front of the numeric value. Right, and then they'll stay absolute. transparent line. Right, no matter where you put it, it's going to stay the same. Same if we drag it. So easy way to keep them constant. And it's helpful if you have a variety of, like you have a whole column of numbers you want to do operations on, right? You can set up the formula, throw in the appropriate dollar signs to keep it the right column or row values constant, and then drag that formula over to get all of them. All right, questions, comments, does that make sense? Cool. Has anyone used conditional formatting before? Got a little bit. So we'll jump to the spreadsheet that we have. Actually, here's a better example. So this spreadsheet I made, friends and I are playing a game called Pandemic Legacy. And it has a variety of cities on the board, and the cities are divided up into 4 colors. There's yellow, red, black, and blue, right? And so New York, for example, is always blue. And so what I've done here is I've actually put in some conditional formatting. So anytime it sees the word New York, it turns it blue, right? So I don't have to type that, or I don't have to make it blue every time, right? And it does that very nicely for me. If I delete it, the blue goes away, right? Same deal if Tokyo is always yellow, or is red, I mean. Same deal. This one's a little more complicated conditional formatting, but we'll jump into it. So in Google Sheets, if you go up to fill color here, down at the bottom is conditional formatting, right? And so what that's doing is conditional formatting means that based on the value of the cell, it's going to format that cell, right? So that formatting could be how the number is formatted, right? So it could make it a percent, or make it a currency value, or give it a certain number of decimal places, or it could change the background color, like in this instance, or it could bold it, so on and so forth, right? So in this case, I've got 4 formulas for the conditional formatting. I'm using a custom formula that actually checks against this list of the names and then colors them appropriately, right? So it's actually checking what color they are in this list and then colors them the same on this sheet. So for Google Sheets here, we'll start a new conditional format, add another rule. So first we're choosing a range to apply it to. Right now it says F22, so it's only applying it to that one cell, which is a pretty common way to do it. I'm going to give it a little bit larger range. We're going to say E20 through J30, right? Or alternatively, you can come out and click and drag and get the area you want, right? And then we choose our rule. So you've got a lot of options here. Custom formulas seems to be the one I always end up doing, because I always want to do something fancier than it probably needs to be. But let's do it. I've been picking on Henry. So if the text contains Henry, we're gonna change the formatting style, and Google Sheets very nicely here just lets you go through the formatting. So we're gonna make it blue for technocrats. So we got that deeper blue. So anything that has Henry in that area is going to get that conditional formatting, right? So that's an easy one. A common way to do this also is, let's say you have a whole bunch of numbers, right? So this stack here, and you just, when you first look at that stack of numbers, it's hard to tell where the high values are. So you can jump into color scale here and give it a nice color scale, right? And right now it puts the minimum value is this dark green, the maximum value is red, and halfway in between is yellow, and then it shades them different values of green into yellow, then into red. It gives you a nice, easy way to visually pick out where the high and low points are. All right, so conditional formatting is a really good one if you're doing a lot of computation and you want to share it with some other people who maybe aren't going to dig into it and just need a quick spotlight, right, of what's going on, right? So maybe you're doing some analysis, going to share it with your boss or your manager. Your manager is going to take that and make some decisions on it. Get some conditional formatting on there and give them a quick, easy way to pick out what's actually important to them very quickly. Right. Charts or graphs, or any questions about conditional formatting? All right. Let's see here. Charts, tables. Most of you probably played around with charts and graphs before. My advice around that is it just takes a little experimentation sometimes to figure out what you want to do and get it the way you want. The hard rules I have are never use a 3D graph, right? So anything that that would give you like that 3D effect is not worth it. It just adds confusion. So like this, right? You visually, you see the green is larger than it should be, right? Larger than the blue here, just because it takes up more visual area, right? But in reality, if we look, that green is 7.6% and the blue is 8.6%. So you're adding confusion unnecessarily whenever you use a 3D graph, right? The technical communication class I took in college had a hard rule: use a 3D graph, you fail the assignment, right? So it was that strict about using 3D graphs because they just add confusion. Comments, questions? I'm just kind of zipping through features. All right, tables. Do people understand tables and filtering? Should I talk about that or move on?
Actually, I think I have a question about dragging cells.
All right, yeah, what has it been?
So you want to have a formula go throughout like an entire column, and like you have a table and you want to, for each row, compute a value based on other things in the row. Is there a fast way of spreading a formula through the whole thing?
Yeah, so let's take this example. Let's see if it actually gets the, it is not. All right, so in this case, right, so I want a column that's 2, 4, 8, 16, 32, right, that doubles every time. Right, so I can actually write this formula to be equals E8. So in this case, I just use the arrow key to move up times 2. Right, so that's going to give me the cell equals 4. Great. Now, if I drag it down, it doubled the cell I was on, because what happens is that it keeps that reference. It's keeping that relativity. So the new formula is going to be one cell above the cell it's in, right? And it's going to keep it that way all the way down. Right, and it's going to keep doubling. Right, so say you didn't want that, right? You add in that $sign in front of the 8, right? Because let's say for some reason I want everything from 9 down to be 2 times E8, right? It's going to keep that $sign keeps it so that it always stays 8. Whereas if you didn't leave that, when you drag it down, it keeps adding 1 value, 1 to that row designation. Right, so the same deal, and it goes both ways. So if you drag sideways, they're all going to be 0 because these are all 0.
Yeah.
But you know, now let's say I wanted to figure out if I start with 1, 2, 3, 4, 5 and double every time, right? This is easy math that you can do, but it's a good example, right?
Mhm.
I can drag that formula over, or I can even drag a whole selected column over. And so now, regardless of what value I start with, it'll show me all those different doubling how many times to get to that. Does that answer your question?
Yeah, I think so. Thank you.
Yeah. Other questions? Dragging cells is kind of a tricky thing, and you don't really get a total handle on it until you try it a bunch and find a lot of mistakes where you thought you understood and it didn't turn out the way you thought it would. All right. Tables. I don't know that I actually have a table. So it seems like the whole spreadsheet is a table, and it kind of is, but there's actually a different designation for tables. And Google Sheets does things a little bit differently. So Google Sheets actually has these buttons up here in each of the columns, right? The drop down arrow here. And one of the options you can do is sort A to Z. It uses A to Z, but if you had a collection of numbers, right? So right, you can sort those into ascending or descending order. And you'll notice that when I sorted column H, right, to be increasing in value from going up, it did all of the other columns as well, right? So it actually did the entire sheet and sorted it. So 85 was in the 4th position, right? Which I'm remembering because of G4, and you notice that these are now out of order, right? So easy way, let's say you have a whole bunch of data and you want to just get it in order so you understand, you know, not based on the order it was entered in, but an order that makes sense, right? So timestamps, largest to smallest, you want to see all your biggest purchases first, right? Because those require more focus. You can do that. And obviously here, since I have a letter in the front, it's breaking like the sorting's a little bit differently. Cool. Yeah, the other filtering's not in here. The other thing you can do, it's a little different in Excel. In Excel, you actually have to declare it a table and then put in the filtering portions. No, these are good examples. And then these arrows will show up once you declare it a specific table, right? And so it's pretty common if you import data, right? It's probably pretty messy. It's probably not in the order you want. It might have some other stuff that doesn't make sense, and you can use that sorting to get it in a nice order. Yeah, here's a good example. So this spreadsheet is populated from a Google form that my team has. So every time someone wants something to be purchased, they fill out the Google form and it populates this big spreadsheet. And so everything just ends up at the bottom. And you can see from the timestamps here, right? Like this data is over 2020, 2019, so on. And so I've got some conditional formatting here, right? So vendors we use a lot, like AndyMark or VexPro, automatically get color coded for me, just so that if I'm going to be placing an order, right, I can easily pick out all of the McMaster things together and make sure, you know, I don't end up placing 2 different McMaster orders or 2 different VexPro orders to make it easy on me. We've also got the value, the total value, right, which is not a formula apparently. Right, we've got quantity and price per unit, and then a total value. And so we could sort here, right? Let's sort K to see. I have a warning so that I don't accidentally make errors. So we've sorted all the things that are quantity 1 first, or not. Oh. I forgot how I set this one up. This one pulls from a different spreadsheet. This is, sorry. And so it undoes all my sorting as soon as I do it. All right. So yeah, so if you had actually entered the values straight up, you could nicely sort and see things that have really high quantity counts, right? Or the highest cost items nicely. Another common thing you do with tables is filter them. In this case, we've got a few filtering views to go through. So there's an ordering view that pulls out specifically the items that have been approved but not ordered, right? So that someone can go through and order them. You can do similar things on Excel as well. Questions, comments?
When you're getting data from a Google form and you have some columns that are coming, maybe I'm interpreting the spreadsheet wrong, but it looks like you have some columns that are coming from the Google form and some columns that are manually entry and some columns are formulas. How do you prevent the manual entry and formulas from being like moved down because the Google form will generate a new row instead of inserting it into an existing row?
How did I solve that again? I think that one, Henry, took me a variety of Google searching to check out how that worked. This sheet is not a good example because I have some scripting in the back that's running to handle some things, and there might actually be a script that handles that portion. I can't remember. It's been a couple of years since I made this, but I think it does it by default now in a new version of Google Sheets where it won't skip, right? So what Henry's asking is, so let's say I've marked, some where I've put in some values down here. When someone fills out the Google form, it'll actually put it in row 215 because it sees that there are already values, and it leaves this whole empty section, right? I think there was an update a while ago, Henry, that actually fixes that for Google Sheets.
All right, thanks.
Yeah. Other questions? All right, so some other features that are interesting to look into if you're looking for next things to add to your spreadsheets are freezing cells. All right, so you can see the bars here. Those are frozen, so this is a pretty big spreadsheet, right? And I always want to have the labels no matter where I am in the spreadsheet. So I've actually frozen the top 2 cells. So you can see here, we've got row 125, but I can still see rows 1 and 2, right? So I can still read that quantity value and that unit of measure without having to remember what they are. Freezing cells gives you that ability so that you can keep your table headings no matter where you go. So it's not quite as good in Excel. It's one of the areas where Excel kind of lags, but you can do that too. Drop-down menus are a pretty good one, especially if you're sharing the sheet with someone else, right? So like Pandemic Legacy here, I've got some drop-down menus that are populated from a list, so I don't have to type out, Ho Chi Minh City every time. I can just select it from the list. Same deal. Those do a little research into how to get those in. It's usually either data validation or there's actually a drop-down option in things, depending on whether you're in Google Sheets or Excel. Named ranges are one that can really really elevate. So we'll jump to this one. It can really make your formulas much clearer. So I've actually got some named ranges in this formula. So you notice how I basically have a variable called total. Total represents a very specific range in the spreadsheet. So does ordered. And so under data, there's a thing called named range. And so you can define, for example, ordered means on the sheet out, it is R3 through R101, right? Which I could type every time, right? Totally fine and work. But by putting a named range and typing out ordered, it makes it much clearer to me what that formula means, right? And I only have a few here, but you kind of get where that's going of you can basically make a variable and define it to be a certain range and then use that in your formula so you don't have to keep remembering what to write every time. It also saves you from making mistakes with how long the range is, or if later you need to change the range, you can go to the named range, change the range to a different area without having to update every single formula where it's used in. All right, so those are kind of the next step up. And then you get into the more advanced features, pivot tables and protecting sheets. Slicers go with pivot tables. Pivot tables are much more powerful in Excel and give you the opportunity, if you have a lot of data, to very easily make subtables, tables that only have a portion of the data, or pivot charts, which use the data very easily to show you something. So, you know, if you have a big set of data, like our big list here, right? If you wanted to make a chart of only the VexPro orders, right? You want to chart out the dollar amounts of every single VexPro order, but only VexPro orders, right? Normally what you'd have to do is sort this whole table to get the VexPro orders and then select the range of the price for just the VexPro orders, right? And then start your chart, which is fine until you resort the sheet and your range now has some totally different values, right? And so your chart doesn't mean anything anymore. Pivot tables and pivot charts essentially just makes a new sheet, pulls, it listens to what you actually want by you specifying, like, I want Vex, it must have VexPro, and then I want the total, and then chart them, and you can do that. So they're pretty powerful. They're a little confusing, and slicers go along with that, especially if you're trying to present data for someone else. Protecting sheets is always good if it's basically like putting a password on things. So as you get more advanced sheets and you don't want people to be touching stuff or messing stuff, you can add protection to that. What are slicers? So slicers, I don't have any good data for this. We'll take this data. Slicers go with pivot charts and pivot tables. This is nonsensical data. Sorry, I didn't bring a good example for this. So slicers give you a nice little like button set that someone can go in and so you see how we have these row labels here, and every one of these row labels shows up in this slicer. So I can go in and click like, oh, I only want 61, or I want to see 49, 50, 55, 56, and 61. right? So it gives you like a on-demand ability to change what you're looking at without having to rebuild the whole table or the chart. They also come on a timeline version, which I use at work. So we have a big list of all the orders, and there's a nice timeline, and my boss can go in and slide it and say like, oh, I want only August to November, right now. And he can just slide the timeline slider and get just August to November. And then later he can go, oh, I actually want the whole calendar year. Change the slider without having to build a whole new chart, a whole new table. All right. Index match. If you're ready to explore that one, it's basically a way to pull from a big list of data, and based on what value you give it, go find an appropriate another value. So if you have a big list of data and you want to, if I give it, let's say Henry, and I want to pull his last name from the list, I can go find Henry and then find the appropriate last name and the appropriate team number from that, and so forth. The index match is definitely one that you want to go search the internet, find some good articles that explain how to use it and read those through. It's not really one that you can get the full grasp of what it does until you have someone explain it to you. Yeah. All right. And then obviously with all these, with Google Sheets and Excel, you can script your own stuff, right? Your own functions, some of your own stuff to happen. Google Sheets uses what's called AppScript, and it's based on JavaScript. And Excel uses VBA, which is Visual Basic for applications. And so here, for example, is some Visual Basic that Ari used to build his spreadsheet. So his sheet here is calculating gear options. So if you tell it a specific ratio you want, it'll tell you what all the different gear combinations you can have to get pretty close to that ratio. One thing you'll notice here is that none of these have formulas, right? There's not a single formula on this sheet. And that's because what Ari did is he put it all in the VBA to actually calculate out, which is one approach. It prevents people from accidentally making mistakes or editing the formulas by accident, but it takes a little bit longer. It's a little bit more complicated. It's less clear what's going on and how the calculations are actually done. So generally the rule that we use at General Mills is if you can do it in a spreadsheet, perfect, do it that way. If you can't quite do it in a spreadsheet and you need to add some VBA or macros, then do that, right? And keep it to a minimum as much as you can. And then if you can't do it with VBA or macros, then that's when we pull out R, which is a statistical programming or statistical analysis language, so that you can actually really get into analyzing sets of data. So same applies to really anything else, right? Do it in the simplest form you can. So if you can do it just right on the face of the spreadsheet, perfect. If you have to get into your macros or your code, go that. And then if you need something more extreme, then take that. Yeah. And then Excel, for example, has quite a bit about pulling in data, importing data, and then really cleaning up your data with Power Query and making sure that you get rid of any bad data, which doesn't sound that bad, like on the FRC scale, right? You're generally pulling in, maybe 100 lines, or you've got a 100 by 20 table of data, right? It doesn't take that long to look through it and see if there's any errors. But once you get to the order of magnitude of having 10,000 lines, right, 50,000 lines of data, it's no longer reasonable to hand comb through your data. So Power Query gives you that ability to do that. questions, comments? All right. Well, thanks everyone. If you have additional questions or comments, I'll stick on. I can answer them.